Good morning, ladies and gentlemen. This is Mr. Morris all the way from Goose Bay. No baby as of yet. It is 1:54 p.m. So I'm still just hanging out, being cool, I guess. So, like I said the other day, we're going to get on to GO and start looking at the Unit 2. You need your pencil and paper handy, please. And let's get started. We have Math 3204. Unit 2, rates of change. Now, this unit is actually the shortest unit out of the bunch. It is the shortest, but there's a lot of information in here, so we're going to have to pay attention, and let's get cracking. Alright, so I want you to write down everything you see on this screen, so I only got 15 minutes, because YouTube only allows a 15-minute video. So let's start. Anyhow, rates of change. They deal with basically how one variable changes with respect to another. Now, simply put, it looks at how one is affected at a certain rate. It can be something as simple as how many heartbeats per minute, how many meters ran per second, or how many beats per second in a song. It is always something per something. Okay, so a rate of change looks at an increase or decrease over a certain amount of, usually it's done in respect to time, meters per second as usual. We dealt a lot with meters per second in Unit 1, but it's more or less got to deal with, say, how one thing is affected over a certain amount of, say, time or whatnot. I can't really think of anything other than time right now, but there can be many different scenarios. Okay? Easiest way to look at this creature is to look at a couple of examples. Okay? So make sure you write this down. Now, I forgot to say, if I go too fast, by all means rewind, write down what it is you see on the screen, because these are your notes. Okay? So, rates of change. We're looking at something over something. Now, before we go on, what's the most common creature we've ever seen when it comes to something over something? A rate of change. You've seen it since about grade 2. Starts with S. L. O. No, it's not slop. Aha! Slope. This is a very important concept in this unit, ladies and jelly beans. The slope. We know the slope is always y over x, and it's always given by rise over run. And essentially what the slope tells us is what? The rate of increase or decrease, which is what? This creature up here, over a certain interval, which is our run. Now, this idea is very important, but it will come back to, we'll come back and see this later on. So, we're going to start out small. I should tell you, though, that later we're going to move on to, first we're going to look at rates of change in simple situations. Then we're going to use the same ideas and push that into quadratic equations, okay? Quadratic functions. Ain't no thing but a chicken wing, ladies and gentlemen. So, just bear with me. Okay, this stuff is pretty good. Ready, set, let's look at an example. Now, we've got example number 1. The high school girls basketball team is selling t-shirts to raise money for the season. They set the price at $20 a shirt, but we're selling an average of only $60 per week. By experimenting, they found on average for each extra $5 they charged, they sold 10 fewer t-shirts. Well, basically, the question is, or don't charge as much for the t-shirts. Anyway, question A says, if they increase the price from $20 to $25, how does the number sold change? Now, if you want, you can pause me and have a chat about it, or you can just listen to me to go on. Okay. Now, if they increase the price from $20 to $25, well, in the question it said, for each extra $5 they charged, they sold how many fewer t-shirts? You should be saying 10. So it means what? It means that they were already selling 60 at $20. So if they increase an extra 5, they're going to lose 10 t-shirts, right? So they're going to sell at $25 actually 50 t-shirts. So what is the average rate of change of sales with respect to the price? As the price increases $5, what happens to the t-shirts? The number of t-shirts sold goes down by 10. That's it. That is the average rate of change. As the price increases $5, the number of t-shirts decrease by 10. B, if they increase the price from $25 to $30, what is the average rate of change of sales with respect to the price? Again, they're increasing from 25 to 30. What's the rate of change? Well, you know that as they increase the price by $5, what happens? They sell 10 fewer t-shirts, correct? So, easy peasy lemon squeezy. What's the average rate of change of sales with respect to the price? As the price increases by $5 per t-shirt, the number of t-shirts sold decreases by 10. Now, it says, explain your findings in A and B. You don't have to do that. We just went through it. What you're supposed to see here is rate of change and how rate of change applies to an everyday situation. You're going to notice that in A and B, though, the rate of change stayed the same. On the same increase of $5, you lost 10 t-shirts. That is very important, okay? Because the rate of change that applies here is not necessarily the same for a quadratic equation, which we're going to build up to. Okay, if you want to copy this down, I advise you to. So pause me here and copy it down. Write out your answers as we discussed. If not, or no, write out your answers as discussed. And when you're ready to go, just hit play. Okay, we should be ready. Let's look at example 2. Example 2 says, David took his pulse when he was resting and counted 20 beats in 15 seconds. Then he did 10 minutes of vigorous exercise and took his pulse again. This time he counted 52 beats in 15 seconds. How much did his heart rate increase as a result of the exercise? Well, again, how much did his heart rate increase? We're looking at a rate of change. Why? Because in 15 seconds when he was resting, it was 20 beats. So, when he did 10 minutes of vigorous exercise, his heart rate increased to 52 beats in 15 seconds. How much did his heart rate increase? Well, simply, it was 52 beats minus, holy mac, big old 2, 52 minus 20, which is an increase of how many? 32 beats per minute. 32 beats in 15 seconds, right? 32 beats per, holy mac, per 15 seconds. Okay, SEC. So, what you see here is a very, very, very simple example of a rate of change. It looks at an increase here in this case. In the other example, we looked at a decrease. So rates of change can work either way, up or down, negative and positive, and you're going to see where that comes in a little bit later on. So, write this example down, please. Take a look at it. You can discuss it if you want. Okay, make sure you're writing it down. Patrick, you better have your notebook, boy. No, boy. Make sure you're all writing it down, guys and girls. Okay, if you need to pause me, but we need to move on, right? Because I don't have a lot of time with the YouTuber. Okay, on your mark, get set, let's go. Now, here's what I want you guys and girls to try on your own for this period, okay? Here's what I want you to try. 3 questions. I want you to write these down. I will talk about these right now, but I want you to write them down first. So you should pause me, then I'll discuss that with you, okay? But I'm going to get you guys and girls to do them, okay? Pause. Okay, now, here's what I want you to do. Number 3 says if a linear function is defined by y equals mx plus c. Now, we are used to seeing this. We're not used to seeing c. What are we used to seeing? B. Guess what? Same difference. Now, what is the rate of change in this case? Well, boys and girlies, I told you in the beginning that what is important here? The slope, right? The slope in this case is denoted by what? M. So, what do you think the rate of change is going to be in this function? You should already have it. It's good old M. Now, next part says, what is the significance of a negative rate of change? I'm not going to tell you that. You can come up with that on your lonesome. Discuss that together, and you should be able to come up with something. Okay? If not, Google it. You can use the computer there in my room. Google it. Now, number 4 says, describe how you think statisticians calculate the birth rate in a country. Well, tell you what. Think about it. But you can also Google it. I would Google. I Google everything. Okay? So just Google it. See where it comes down. And see what happens. Okay? Number 5, and many sports data are collected to help coaches and athletes improve performance. Very often they are reported as rates. Choose a sport you are interested in and see if you can find any rates that are used in analyzing performance. Now, this one, number 5, here's what I want you to do. Okay? Number 5, I want you to, because there's only a small group of you, agree on a sport, and I bet you that George and Patrick, volleyball, and Kendra. It doesn't have to be volleyball. Very often times hockey have very good statistics and such. Look at the rates. It could be meters per second for a runner. It could be goals against average for a goaltender. Points per game for a player. But just look at it and see if you can come up with a few and just jot them down in your notebook. So these are what these are what I want you to try for this period. If you get these done before the period is over, guess what? I want you to, yes, exactly, review. Okay? I want you to continue going over Unit 1 because as soon as I get back in the driver's seat there, I want you guys and girls to start actually do an exam. So if you get this done before the period is over, which I think you will, go ahead and review Unit 1. Number 4 and 5, I want you to Google that together. So you do it as sort of a group effort in my room. Okay, use the computer, use the smart board, and just work on these. All right. Well, this is Mr. Moore signing off. So rates have changed. New idea. New in that we quantified it for the first time, but you've seen this a million times. Really, we're looking at slope, and we're going to get into that a bit more next day. All right, ladies and jelly beans, this is Moore's, over and out.